Page 305, question number 9. Two cars, A and B, each have a mass of 1.20 times 10 to the 3 kilograms. The initial velocity of car A is 12 meters per second, while car B is 24 meters per second. Both cars increase their velocity by 10 meters per second. So, we have two cars, A and B. The mass of each car is 1.20 times 10 to the power 3. Car A starts at 12 meters per second, so V initial is 12.0 meters per second, and car B starts at double that, 24 meters per second. Both cars increase their velocity by 10 meters per second, so car A is going to start at 12 and finish at 22. So V final will be 22.0 meters per second, and V final over here will be 34.0 meters per second. And it asks us, calculate the gain in kinetic energy of each car. So the change in kinetic energy will equal the final kinetic energy minus the initial kinetic energy. So we're going to have mv final squared divided by 2 minus mv initial squared divided by 2. Now, because we have mass in both and divide by 2 in both, we can factor that out and say that this is going to be 1.20 times 10 to the power 3 kilograms divided by 2. We have v final squared, so 22.0 squared minus v initial squared, which is 12.0 squared. If we do that same calculation for B, we're going to have our 1.20 times 10 to the power 3 kilograms divided by 2 multiplied by v final squared, so 34.0 squared minus v initial, 24.0 squared, close brackets. Again, in both cases here, remember you must square the velocities before you subtract them. So 1.2 times 10 to the power 3 divided by 2 times brackets 22 squared minus 12 squared gives me a value of 204,000 joules. That would be 2.04 times 10 to the power of 5 joules is the change in kinetic energy going from 22 to 12 meters per second. And in this case, 1.2 times 10 to the power 3 divided by 2 times bracket 34 squared minus 24 squared means we're going to have 384,000 joules. So 3.84 times 10 to the power of 5 joules as our change in the energy. Part B says, if both cars gain the same amount of velocity, why do they gain different amounts of kinetic energy? Well, our kinetic energy depends on the square of the velocity. So because they're gaining the same amount of velocity, but we're squaring it for the energy, they end up with very different amounts of energy. So if we compare this, we have 22 squared minus 12 squared. So if we put that in the calculator, 22 squared minus 12 squared, this value gives us a change of 340. Over here we have 34 squared minus 24 squared. This one gives us a value of 580. So that's why we end up with very different amounts of energy, even though they have the same mass and they have the same change in velocity. They started at different velocities, so they will get different square of changes of velocity.